Now let's delve into the this pointer a little more. Now why do we even need the this pointer? Remember that in the class memory, we have all our static members, right? Also, all of our methods also are in a memory which is not exactly in the object. So when we create an object of this particular class, it will only have its instance variables. Now, if you are executing any method from this, the method is actually supposed to change, let's say, the instance variables. How is the method going to know which object to change the instance variable of? There may be other objects created of this class as well, right? So to understand which is the object for which this method is now binding and is now changing the instance variables, we have to use the this pointer to make sure that this is the object which has called you and this is the object for whom you are going to change the instance variables. That's why we use the this pointer. So now to show to you the use of this pointer, I have created the this.java class, and here again, I just have my main and I copied the attendance class, except that I changed its name to classroom now and remove the comment. So essentially the code is the same which we were using earlier. Now in this, we already saw that we could use the this pointer to call a particular constructor. So here we are using the this pointer to call the constructor which is taking just one string argument and it's updating. And we also saw that we are using this pointer to call to signify the instance variable over here. So these are the two uses of this pointer which we saw. Now let's say if we have a method which is actually going to take an object of this particular class. So just like this constructor, we may have another method which is taking the object of this particular class and let's say returning the class name. Okay, so it will take attendance, for example, A, and it's going to return a dot class name. Okay, now the name of this method, let's say, would be get class name. So now if we want to call this particular method get class name from any other method, let's say for example over here we have this particular get class name, but this is without any arguments. And what we can do is, instead of just returning class name over here, we could actually call this particular get class name and pass on the current object which is calling this. So if the object calls the get class name, we want to pass that particular object. Now how do we know which object is calling? Again, using the this pointer. So here we have some error. It's not that we should use attendance, it's actually that we need classroom because I just changed the name, right? So now let's try to create a new classroom object. So classroom C equal to new classroom, and let's just pass the class name over here as well, Java. And what we want to do is C dot get class name, and that's it. Let's try to run this. And we do not get anything because we do not have a sysout over here. So let's just do a system.out.println and save this and run this. So now we have Java over here, just because it called the get class name out here, but then the get class name actually called another get class name passing the this pointer, and this is actually taking the classroom A and then it is returning a dot class name. Now you might be thinking that how can we have two methods of the same name, and that's something which we are going to see going ahead. Now similar to how we have passed this to a method, similarly this object can be passed to a constructor as well, just like this. So here, instead of attendance, if I would have had classroom, I could easily call this particular constructor just by passing the this pointer. Also, if I want to assign another object with this new object, so let's say I just create a classroom C equal to new classroom, that's it. And what I want is that in this C1, I want to assign C. So let's say if I want a method, let's say assign to other. Essentially want is that this assigned to other should return an object which would be assigned to C1. So here again we have an error just because we do not have this method. So let's just create a method over here. This is very easy with Eclipse. As you saw, I could just click on that error and it gave me a method body public assigned to other, and it is returning the classroom object. And here this is just generating this stuff for me. I'll just delete that and I just want to return this pointer. So what essentially this is doing is that this object C is calling this method, and this method is actually returning the entire object C for C1. So now if we just try to print out the class of C1, let's see what we have. You can see that we have C1's class name to be Java, although we did not define any class name for C1, right? Just because it returned the entire object for us. So this is how we could use this pointer. So we saw how we could, use this pointer to refer the current class instance variable. We saw how we could use this pointer which would invoke the current class constructor. This pointer would also pass an argument in the method call or in a constructor call. It could also return the current class instance from the method which we just saw right now. So that's it about this pointer. Hope you do not have any confusion with this example. The key to avoid any other confusion is to keep practicing. Whatever I'm coding, you can keep practicing along with me, and then you will be able to understand how things are working. Now let's discuss something about scope. What is the meaning of scope? Scope shows what is the lifetime and what is the area in which that variable can be accessible. Now, for example, in this class and in this main method, if I just create an integer scope test equal to 1. Now, if I want to access this scope test over here in my get student count, I want to write scope test equal to 2. Now it's giving me an error and it's saying scope test cannot be resolved to a variable. Why? Why are certain variables not able to get resolved in certain places? Just because their scope is different. Integer scope test is not over here. The scope of this integer scope test is over here. So now if I just use scope test equal to 2 over here, now it's simply assigning scope test to be 2 and without any issue. So what is this scope? And how do we know that where can certain variables be accessed? So the first thing is instance variables. So as you can see, class name is an instance variable since it's a non-static variable. Now instance variable can only be accessed within this particular class or using an object of this class. For example, we created an object C. So I can use C.className and I can, let's say, assign something else, for example, data structures. And this would not be an issue. But if I just write class name, then there would be an error because it would say that class name cannot be resolved to a variable because this is an instance variable. It has to be accessed using an instance only. Similarly, we have static variables or class variables. Now, these can be accessed using the class names and not necessarily an object name, which we just saw. For example, if I would have done classroom.className, this still wouldn't work. Why? Because it says that cannot make a static reference to the non-static field classroom.className. So, but can we do classroom.studentCount? Absolutely we can, right? So this is not going to be an issue. If we assign any other integer to this, this is not giving us any error. So these are the two scopes. The next thing which you need to know is a method scope. So whatever you define inside a method, you cannot access it anywhere outside that. So let's say I create a new string demo class, okay, and I would just write that this is the demo class for Java programming. Okay, and now I want to access this demo class from, let's say, set class name. I cannot do that. Even if I try to assign something else to it, is this cannot be done because this is only available within this method. It cannot be accessed anywhere else, not in any other method, not in this class, not outside this class. So all the variables which you create within a particular method are accessed only within those methods. Similarly, if you have any arguments like this classroom A, you can access this A only in this particular method. You cannot access this A, which is an argument of this method, in any other method or in this entire class as well, or in another class. So now we know in scope that there are static variables, there are instance variables, there are local variables to various methods. We know that in functional scope, the variables defined within functions, within methods, are available only within that particular function. And remember that methods cannot have methods within them. So if you are coming from another background in which you have learned any other language like JavaScript, it would have functions within functions, but Java does not have methods within methods. Now let's look at one of the most important principles in object-oriented programming, which is inheritance. So to show you that, I'm going to create a new class called as inheritance. And now over here, we would have a main as usual. Now let's consider a problem in which you have a number of vehicles. So we already took an example of a vehicle class, right, earlier. So the vehicle class would have speed and color. So each vehicle would have some or the other color, and it obviously has some speed, right? Now there are different types of vehicles because earlier we wrote for the vehicle start and stop. So the starting could be driving, it could be riding, it could be flying, it could be sailing. But so different vehicles can have different methods. They can have different attributes as well. So for that, let's consider that I create a class of car and a class of bike, a class of train, a class of boat, etc. And each of these would have at least the color and the speed in common, and there could be many more things. So my idea is that why can't I have all of these things in one place, let's say in vehicle, and I want to actually use all of these things of vehicle within my other classes. And remember that this entire thing which I want to do is a relationship, meaning that car is a vehicle, bike is a vehicle, train is a vehicle, and boat is a vehicle. Okay, so this is an is-a relationship, and whenever you have an is-a relationship, you would want that all these variables and all the methods of the vehicle class should be available for my other classes if I create for car, bike, train, and boat. And I should be able to have that flexibility add on to all the common things over here. Now, how do we do that? For that, we need inheritance, and we use a keyword which is extends. So let's create a class vehicle, and over here we would have string color and integer speed, and let's make both of these public. And let's add now the getters and setters as well. Now, other than this, let's not have anything else. Now let's create a new class called car. So this is class car. If I want everything of vehicle to be available for car, I will have to extend it using the extends keyword, and this will extend the vehicle class. When car is extending the vehicle class, all these things are available for the car. Now we can add other things like public string model, let's say, and then we can add a method, public void ride, because we ride a car, right? Sorry, drive. We drive a car. Okay. And then this is just going to print I am driving the car. Okay. Now let's add a getter and setter as well. Okay. Now let's just save this, and in my main method I'm creating an object of the car class. So car Mercedes equal to new car, and I want to make sure that this Mercedes car has a model of, let's say, Mercedes Benz. Okay, this is just an example. Now what I want is that I want to set its color and speed as well. So Mercedes dot color, let's say it is black, and Mercedes dot speed, maybe it can be 300 kilometers per hour. So this is where I set all my variables, and I want to now call the get speed method, and I just want to also call the drive method. So now when we call the drive method, it's going to print it for us. If we just, get this Mercedes speed, then, we will have to system.out. And over here, if I just want to add some information before that, driving at speed, and then with a plus operator, these two strings. So Mercedes dot get speed will return a string, and so even if it returns an integer, it will, automatically be converted to a string just for system.out.println. And it's this plus sign is going to concatenate both the strings and then display that to you. So when I save this and when I print, you can see over here, I'm driving the car, driving at speed 300. So this is the thing which is helping you understand, even though we created an object of the class car, but we could actually set its color and speed, which is not present within it, right? Color and speed is not present over here. Color and speed is present in the vehicle class, but just because the vehicle class could be extended by the class car, then we have all these attributes as well in this. So we have our model, which is a part of the car class. We have color and speed, which is a part of the vehicle class. We have the drive method, which is a part of the car class, and we could get speed, which is a part of the vehicle class. So as you can see over here, I can simply reuse the things from my vehicle class in my car class or any class which we want to inherit vehicle from. So now I can create different classes, like I can create a class bike, which extends vehicle. I can just, create a new method for ride, and then, I can have class boat extends vehicle, and, I can have another method for sail. And let's say I can have a class train extends vehicle, and probably you can have methods like pull out or pull in, etc. So these are the various ideas behind using inheritance. Now you can have different types of inheritance. So right now you saw that my vehicle class was extended by the car class. So the car inherits from the vehicle. You will call vehicle to be the parent class and car to be the child class. Or vehicle is the superclass and car is the subclass. Or vehicle to be the base class and car would be the one who is extending the base class. Okay, so if you have this super and sub or parent and child, then this is known as inheritance. You could have this type of a single inheritance, but you could also have a multi-level inheritance. For example, we created a class car from the vehicle class. I could also create an entire class for Mercedes and extend the car class just to have all the attributes within the car class and within the vehicle class as well. So both the attributes, both the methods of these two classes will be available for Mercedes, and it can add its own attribute, its own methods as well. So this is known as multi-level inheritance, in which one base class is extended by another class, and then that class is extended by another class. You could also have a hierarchical inheritance, meaning just like I showed, right? The car can inherit from vehicle, even the a train can inherit from vehicle, and multiple other classes can inherit from the same parent. Now, another type of inheritance is possible in other programming languages, which is known as multiple inheritance, in which, a new class can inherit from multiple parent classes. But in Java, that is not allowed. In Java, you can only extend from one single class. You cannot extend from multiple classes. Now, why is that so? That is because if you extend from vehicle, let's say car and train is extending from vehicle, and then I create a new class, my transport, and I just want to extend car, train, and other classes as well, just to make sure that my transport has everything about the car, everything about the train, and all the other things. But then there would be multiple versions of the vehicle variables and methods, right? Because the vehicle variable and methods are also present in the car class. The vehicle variable and methods are also present in the train class. So all these same copies of the data is present in all these different classes, and then I'm just extending from these classes. So now how many versions would I have, and which version would the compiler use whenever I do a call for a particular method of the vehicle class or a particular variable of a vehicle class? Now that really becomes confusing. It is known as ambiguity. Ambiguity is there because it is not able to design exactly what you want. And whenever there is ambiguity, there is definitely a lot of error issues, right? So that's why Java does not allow that. There is no multiple inheritance. You cannot extend from multiple parent classes. All we have is single, multi-level, and hierarchical inheritance. Now, what about static variables? Now, in my vehicle class, I created a static variable vehicle count and initialized it to 0. And in my car class, I actually created an constructor. Whenever an object of the car class is created, then my vehicle count should increase. Now, here we created a car class, right? We created an object, Mercedes. So now I just wanted to print the vehicle count from Mercedes. And as you know, that we don't really need to call vehicle count from Mercedes. We can simply call the static variable from the car class. The idea is that is the static variable from the vehicle class inherited to the car class just to be called by this name. So let's try to run this. And as you can see that now the vehicle count is 1. That means I am able to access the static variables of parent class as well from the child class, and I'm able to actually use the static variable directly. I could also use a keyword to access other variables of the parent class. For example, I could just use super dot, and then this is also going to work the same way. If, let's say, for example, I wanted to call get color within this. So over here, let's say in my drive method, I also want to share the color of my car is, and then I want to actually access get color, which is a method of the parent class. So if I just write get color, and let's try to run this. So now we are able to access the method of the parent class as well. So this is how we can actually access everything, all the variables and all the methods from the parent class in the child class, whether they are static, whether they are non-static. And we could also use the super keyword to access certain variables which would probably have the same name. For example, let me just create a new public int x equal to 0, and here I would just write public int x equal to 1. Now the name of this variable in the child class and the parent class is the same, right? Now if I just write that x is and then I would just write x. Now when I run this, you will see that x is 1, because in my car class x is 1. What about if I want to access the x of the parent class instead of the child class? For that, I need to use the super keyword. Without this, it will not be resolved, because here for the child class and x for the parent class is different. So now when I save this and when I run this, as you can see over here, x is 0 now. So this is how we can differentiate between any variables which are having the same name than the one which is there with the parent. And that's where the compiler also makes the difference. If the compiler sees super dot, it understands that, okay, that's the version of the parent I have to use. If we avoid super dot, then it understands that we are simply accessing the child part of the variable only. And similarly for methods, if there are any methods which are static, you will be able to extend that and simply use those static methods within your child class, and with the object or with the direct class definition, and you can simply call the static method as well. So that's how inheritance works, and that's how it gives you a lot of flexibility while working. And the magic doesn't stop here. Let's continue with other concepts which will give you so much of flexibility while working with Java, and you would simply start loving this language.